Assalamu alaikum students. Today we will study the MATLAB code of Gauss elimination method. Gauss elimination method, as we have studied earlier in the theory, is that it involves only two steps. That involves the row operations, and step number one is that you have to convert the matrix into the upper triangular form, and step number two is you have to convert it back the matrix into a equation, and then step number two is that you have to use the back substitution process. So these two steps I will tell you that how to apply in MATLAB. So first of all, what we need to declare the function and its input and output. So in this we have to study about the output should be the variables or the unknowns or the column vector of unknowns, and that is equal to x is equal to, name it like any name like Gauss, and you have only two inputs. That one is the coefficient matrix and the other one is the constant vector. So a comma b, and then in the next line you have to write down the coefficient matrix. So we have studied in the theory. I will write it 1 2 1, then this column semicolon, and then 2 3 4, and also 4 3 2. So this is the coefficient matrix, and then the B column vector is, because it is a column vector, so you have to be aware of writing. Don't write in the row form. It is a column vector. It involves 3 rows and 1 column. So check out the size for this. It should be a scalar matrix. So 8 colon 20 colon 16, 3 rows and 1 column. So this is the coefficient matrix. And also now declare the size of A. So what you need is the size of A. It may be a 3 cross 3 matrix. Now this command size of A will judge that what is the dimensions, what are the dimensions of this matrix. So n comma n, it should be a scalar. Its dimensions should be same, like rows should be equals to column, and that is equal to size of A. So this will judge the size of the coefficient matrix, and also to judge the coefficient, to judge the size of the matrix B column vector, you have to so that you can find out the unknowns, because unknown vector has the same dimensions as the B vector. So if I write it n comma k, you can also write it n comma 1. So I am using the generalized matrix n comma k is equal to size of B. Now this will automatically take the dimensions as 3 cross 1. So this is all you need. And one more thing is that you have to initialize the column vector of unknowns. So for that you need x equals to zeros of, zeros is basically the 0 0 0 3 columns in one row. So zeros same dimension as the B vector. So n comma k, and that's it. So these are all the steps you have to do before using the row operations. Now we come to the step number 1, and step number 1 is to convert the matrix into the upper triangular form. So for I equals to 1 to n minus 1, so that will take the values accordingly. So that means m. Okay, what is m? Let me tell you. And m is equal to minus a of I plus 1. I plus 1 is basically it involves the row operation. So let me write this, and we'll tell you later on that what is the purpose of this m factor. comma I. So basically your I dimensions changes from rows dimension changes from I plus 1 to n comma I, and all the columns involved, but the row is from this to this. So that means first operation is from I is 1 for 2 2 3. Total dimensions are 3, so 2 to 3 rows and all the columns 1 2 3. Okay, so divided by a comma I. So what this vector will do, this will generalize all the vectors, because we have to reduce it into the, convert it into the upper triangular form. So below the leading entry, like below the A11, you have to take that vector. For example, in this matrix, this first entry below the A11 is 2 and 4. So M is that vector that makes it 0, that multiplies with the R1 row 1, and add and subtract means that makes it 0. So if I want to make this 0, then I have to multiply this R1. So basically it's a row operation, that is R2 minus 2 into R1. So minus 2 is that M at in the second row. And if we want to eliminate this, make it 4 is equal to 0, then you have to use the row operations is R3 minus 4 into R1. So M in the third row for making it 0 is 4. So M is the generalized version of the coefficient that makes it 0. So I will tell you, if I make it, if I remove the semicolon, then it will display the that factors, 0 factors for this. Okay, now we come to the row operations. Now row operations is a of I plus 1 to n comma colon means for a fixed, all the columns are going and the rows are changing from this to this. So that is equal to, because R2 is equal to R2, because we have to change, make a change in R2 and R3 to make it 0 below A11. So only change will be in the R2 and R3, I plus 1 to n comma that colon and plus, because M here I am writing it like negative as a common thing, so it makes the addition or subtraction accordingly. So M multiply by AII, sorry, AI comma colon accordingly, because here the columns are changing but the rows are fixed like 2 to 3. The changes should be R2 and R3. So these two steps, this one step will make R changes in R2 and then R3 and all the columns accordingly. So this is column here. Okay, same changes, because it is an augmented matrix, so same changes will be done in the constant vector. I plus 1 comma n, sorry, I plus 1 to n column, because columns are changing accordingly and you have to use only row operations for this. So same step for this, I plus 1 to n comma colon plus m multiply by b, and it is accordingly same operation for this. Okay, so this is all about the row operation. So step number 1 is completed. Now you have to use the back substitution. Back substitution means if you have 3 cross 3 system, then first is that you have to convert it into equation. Equation third is solve firstly, and then equation 2, and then equation 3. So you have to use it in the reverse order. So I am using this loop I Okay, one more thing is that you have to, because third row has x3 and x3 has the coefficient, so the third unknown will be determined if you divide that coefficient with the constant in the right hand side. So x n means 3, and all the columns along with this is equal to b and b3. That means b3. So b3, all any constant in the right hand side, divided by the coefficient with the left hand side in the third equation. So this is basically the third equation, and you have to then use in the you have to move ahead in the reverse order. So a n comma n means 3 cross a33, basically it is a coefficient. Okay, so let me write this and then I will explain in the comment section. So this is basically x3, and then you have to go in the reverse order. For I is equal to n minus 1, and minus 1 means reverse order, and 2 1 till the first equation you have to do this, and this x comma I colon is equal to b, and this is all we have to done, because the coefficients like x2 for I is equal to 2, x2 can be determined by b2, and all the column accordingly, minus a multiplied by all the coefficients along with the other unknowns. Okay, so I to now the columns are changing. Now there is no row is fixed, but the columns are changing. I plus 1 to n. Make sure that it is not the same column. Make sure it is not the same unknown. So x2, that means I plus 1 to n, and row is fixed here, multiply by the other unknowns. If you want to sort out the x2, then in that you have to replace the value of x3 and x1 accordingly. And if you want to find the x1, then b1 minus that coefficient multiply by the unknowns, like a11 multiply by, sorry, it's not a11 in the first row, x1 is equal to b1 minus a2 into x2 minus a12 into x2 minus a13 into x3. So that is the that I was trying to tell you that it is the change in the basically the columns in a specific row. So these are the other two constants, I plus 1 to n, comma, column. So columns are changing, but row is one here fixed. Okay, divided by I. Okay, so that means if you want to find that x1, then it means a11 is divided here, and this whole operation is in the right hand side. In short, I can say that if you want to find x1 is equal to b1 is equal to b1 minus a12 into x2 minus a13 into x3 divided by a11. So that is that step, and that's it. It is done. So these are the factors. If I want to remove this, and if I want to remove this, okay, so here you can see the output that in the first factors, these first factors are, if it is 2, you have to make it 0, then m is minus 2. If you want to make this 4, the R3 factor 0, is equal to minus 4, and then your first column has 1 0 0, and if you move further, your the next matrix will be a modified matrix, and according to that your row operation, you have to use your row operation in that factor. If it is 5 below that A22, then the A32 is basically 5, so you have to make this minus 5 to make it 0. You have to multiply with R2, and then x is basically initialized here. Zeros and k means that 3 comma 1, so it is 0 0 0 basically. And if you modify this row operation, then this 12, line number 12 by line number 12, b3 divided by a33, that is equal to it comes the value 3. And then you have to modify by these reverse process back substitution. So if you modify, then x2 is equal to b2 minus a2 3 into x3, okay, divided by a22, so that makes it 2. And also if minus 1 to 1, so if you reach to the equation number 1, then x1 is equal to b1 minus a12 into x2 minus a13 into x3 divided by a11. So that makes it 1 2 3. So the answer is 1 2 3. So this is all about the Gauss elimination process, and I hope that you understand. Make sure that you understand this program, because in the further Jacobi's method and Gauss Seidel method and Lagrange interpolation and divided differences, we all will follow this concept of row operations and this concept of column operations accordingly.